to our maths class. Previous class we discussed about the Euclid division lemma and Euclid division algorithm. We are continuing. And what is mean by prime numbers? Prime numbers means which is having only two factors. The factors will be 1 and the number itself. That numbers are known as the prime numbers. The smallest prime number is 2. Composite number means that numbers will have other than two factors. Normally, suppose we are taking 4. Which all will be the factors of 4? 1, 2 and 4. Therefore, it is having 3 factors. Therefore, 4 is a composite number. Then, prime numbers, for example, prime numbers will be, we can take smallest prime number will be 2, 3, 5, 7. Is it 9 prime number? No, because 9 we can express as 3 into 3. 1 into 9 also. Therefore, its factors will be 1, 3 and 9. Therefore, 9 have 3 factors. Therefore, it is not the prime number. 7, 11. Then it is going on prime numbers. Composite numbers. One is neither prime nor composite. Composite number means we can take 4, 6, 9, 10, 12, like that. All are the composite numbers. Just look, 4 means we can express 4 is equal to 1 into 4. Then other way 2 into 2. Therefore, the factors of 4 is equal to 1 to 4. Then 12 if you are taking 1 into 12 we can use. 2 into 6 we can take. 3 into 4. Therefore, 1, 2, 3, 4, 6, 12. All are the factors of 12. Therefore, the composite numbers will have more than 3 factors. Next, I am taking this 4. You already know that 4 is a composite number. How we can write this 4? 4 we can write as 2 into 2 we can write. This 2 is a prime number. This also prime number. Next, I am taking 6. 6 also we can write 2 into 3. Then 9 we can take as 3 into 3. 10 we can take 2 into 5. All. Therefore, this all are the composite numbers. The product you got, all are the prime numbers. Then, every composite number can be expressed as the product of primes. All these 2, 3, 5, all are the prime numbers. These all are the composite numbers. Then we can conclude that every composite number can be expressed as the product of primes. This is known as the fundamental theorem of arithmetic. Then what is meant by fundamental theorem of arithmetic? Every composite number can be expressed as a product of prime, and this factorization is unique apart from the order in which the prime factors occurs. These all are the prime factors, and this will be here what they told, and this factorization is unique. Every time you will get the same factorization, prime factorization we are using, and this factorization is unique apart from the order in which. Here I have written 2 into 3. If it is possible, we can write 3 into 2. Then this factors of 6 contains here also 3 and 2. Here we have written 2 first, second, 3. Therefore, if you are not looking the order of the numbers, this factorization is unique. Order in which the prime factors occurs. These are the prime factors of 4. All these are the composite numbers. Every composite number can be expressed as the product of prime, and this prime factorization will be unique. Only one type only you will get, except the order of the numbers will change. Here I have written 2 into 5. If you are writing 5 into 2, then also the same factors are there, 2 and 5. This will be the fundamental theorem of arithmetic. Then we are using this fundamental theorem of arithmetic for finding the HCF of two numbers. That we already studied in lower classes. Just we can revise. Find the HCF of I am writing one question. find the HCF and LCM of 6 and 20, 6 and 20 by find the HCF and LCM of the integers by the prime factorization method. By prime factorization method. Prime factorization method, or if they are saying by the fundamental theorem of arithmetic, both are same. Otherwise the question will be like that: find the HCF and LCM by fundamental theorem of arithmetic or by prime factorization method, both are same. Next we are writing the prime factors of 6. 6 you already knows, 2 into 3. Next 20, how we can write 20? We can take 2. Prime numbers only we can use 10. You are getting 5. Then 2 into 5. If you want, you can write this only 1. Thus you can write as 2 square into 5. 2 here repeated 2 times, therefore 2 square into 5. Then what is the mean by HCF? HCF means highest common factor. Here 6 you got 2 into 3, 20 you got 2 square into 5. From this, what will be the common number? From 6 and 20, 2 only will be the common factor. Therefore, out of this, lowest power you want to choose, that will be the HCF. Here you got 2 and 2 square will be the common. From that lowest power, exponent you want to look, that lowest one you want to choose. Therefore, HCF is equal to 2. Then, next you want to find out the LCM also. Here, HCF means I already told highest common factor. Common number you want to look. Out of that, smaller exponent you want to take. That will be the highest common factor. In the case of the LCM, least common multiple. No need of looking common factors. Whatever numbers are there, its highest power you want to take. Here 2, here also 2. The highest power will be 2 square. Then 3 only here. No, here in the second number no 3, but you want to choose that 3. Then 5 here only, that also you want to take. Then that will be the LCM. 4 into 15. That is equal to 60. Therefore, HCF is equal to 2, LCM is 60. Then you understood that first you want to take the prime factors of the numbers 6 and 20. HCF means highest common factor. First you want to look the common numbers from the both the numbers. Then lowest power you want to choose. Here common numbers means 2 and 2 square coming common. Then the lowest power you want to take, that will be the HCF. LCM means the highest power of the numbers you want to choose. 2 and 2 square are there, therefore you want to choose 2 square. Only 1 3, therefore you are choosing 3. Only 1 5, therefore we are choosing that 5. Suppose here 3 and 3 square also there. In the case of the LCM, we will take that 3 square. If here 5 only, here 5 square is there, that time you want to choose the highest power. Therefore 60 will be the LCM and 2 will be the HCF. Is it clear? Next we can do one more question. Next I am showing one relation. I am doing HCF into LCM. What will be HCF here? 2. LCM is 60. Then 2 into 60 you are getting 120. Then I am doing these two numbers. Product of numbers. Product of numbers. What will be the numbers here? 6 and 20. Then 6 into 20. That also you got 120. And I am showing one result also. That is HCF into LCM of two numbers. HCF into LCM of two numbers is equal to product of that two numbers. HCF and HCF into LCM of two numbers is equal to HCF and LCM of two numbers is equal to product of that two numbers. That means HCF here you got 2, LCM you got 60, 2 into 60 you got 120. Which two numbers HCF and LCM you find out? 6 and 20. Therefore 6 into 20 also you got 120. Therefore we conclude one result also. HCF into LCM is equal to product of the two numbers. This is only true for two numbers only, because two numbers HCF and LCM if you are finding, that time only it is applicable. Suppose that we are finding the HCF of three numbers, suppose 3, 15 and 20, then this result will not be true. If you are finding the HCF and LCM of two numbers only, then this result will be true. That is, product of two numbers is equal to HCF into LCM of two numbers. Next we are going to do one more question. Find the HCF of 96. Find the HCF of 96 and 404. 96 and 404 by prime factorization method. By prime factorization method. By prime factorization method, hence find their LCM. Hence find their LCM. Find their LCM. First we can find the HCF of 96 and 400. First we can take the prime factorization of 96. We can take 2, 48, again 2, 24, again 2, 12, 2, 6, 2, 3. 96. We can write 2 how many times? 5 times. 2 raised to 5 into 3. Next we can find out 404. 2, 2, 0, 2. 2 we can take 1, 0, 1. Then we can take 404 is equal to 2 square into 101. Because 101 is a prime number, therefore we can't further divide 101. Then HCF means I have already told highest common factor. Here common number means 2 only the common number, its smallest power. Therefore here 2 raised to 5 and 2 square will be the smallest power. Therefore 2 square, that is equal to 4 will be the HCF. Then what they told, find the HCF of 96 and 404 by prime factorization method, hence find their LCM. Then if you are taking 96 and 400, we knows that the HCF into LCM is equal to product of two numbers. Then we can write HCF into LCM is equal to product of two numbers. That your result we knows. If you are finding the HCF and LCM of two numbers, then only we can utilize this. Other than two numbers are coming, this result is not true. Then HCF you got 4. 4 into LCM is equal to 96 into 404. 404 Then LCM is equal to, here into is there, if you are taking this side it will become division. That is 4. If you are cutting, this will be 101. Then 101 into 96. 9,096 will be the LCM. Then the same way we can find out here, LCM means power, highest power. Then 2 raised to 5 into 3 into 101. This way also we will get. This is the another method. HCF into LCM is equal to product. Then 9696 will be the LCM. Next I will show how we can find the HCF and LCM of 3 numbers. Find the HCF and LCM of, find the HCF, find the HCF and LCM of 672, 6,72 and 120 by prime factorization method. By prime factorization method. Then first we can write the 6 is equal to 2 into 3. 72 we can make 2, 36, 2, 18, 2, 9, 3, 3. Therefore 72 is equal to 2 cube into 3 square. Then we can find out 120. 120 we can use 2, 60, 30, 2, we will get 15, 3, 5. 120 is equal to 2 cube into 3 into 5. Then HCF is equal to, here you want to take the common factors of the 3 numbers. Here what will be the common coming is 2. Then which are the common? 3 is the another common number. Then HCF means from the common numbers you want to take the smallest power. Here the smallest power means 2. Then 3 is the smallest power is 3 raised to 1, that is equal to 3. Therefore HCF is equal to 6. Then we want to find the LCM. LCM is equal to, LCM means we want to take the highest power of every number. Then here 2 cube will be the highest power. Out of 3, 3 square will be the highest number. Here 5 only there, that is 2 cube means 8, 3 square means 9, 9 into 5. Then 40 into 9, 360 will be the LCM. And we can, I already told, if you are finding the HCF and LCM of 3 numbers, that result is not true. If you want, you can verify that. 6 into 72 into 120. We want to find out. 72, 720 into 72. Thus you are getting 51,840. Next 360 into 6, HCF into LCM. You will get 360 into 6. 2160. Therefore, thus product of 3 numbers not is equal to HCF into LCM. Next I am doing exercise 1.2, question number 7. All of you listen. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Once again, there is a circular path. Sonia takes 18 minutes to one round of the field. Sonia takes 18 minutes. Sonia takes 18 minutes, while Ravi takes 12 minutes. Ravi takes 12 minutes to 12 minutes for the same. He completing within 12 minutes. Suppose they both start at the same point and at the same time. They start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Thus, you want to find the LCM of 18 and 12. We want to find LCM of 18 and 12 we can find out. We already know that 18 is equal to 18 to 9, 3 into 3. 2 into 3 square. 12 is equal to 12. We can take 2, 6, 2, 3. Therefore, 2 into, that is 2 square into 3. We know that LCM means highest numbers, highest power you want to take. Out of 2, 2 square will be the high. 2 square will be the highest number. Out of 3, 3 square will be, that is 4 into 9. After 36 minutes, they will meet again. After 36 minutes, they will meet again at the starting point. Is it clear? Here I have not written the question. That is exercise 1.2, question number 7. Next question. Exercise 1.2, question number 5. Check whether 6 raised to n can end with digit 0 for any natural number n. For any natural number n. This type of question. What is the question? Check whether 6 raised to n can end with the digit 0 for any natural number n. First we want to write the, how we can write the 6 raised to n. Just make the prime factors of 6. That you already know that 2 into 3 all raised to n. Then the prime factors of 6, 2 and 3 only. If the number want to end with the digit 0, the prime factors will be 2 or 5. Here the prime factors only 2 and 3. Therefore, the 6 raised to n cannot end with the digit 0. Then 6 raised to n, the prime factors of 6 are 2 and 3 only. 2 and 3 only. Therefore, 6 raised to n cannot end with the digit 0. Then we can again write, if the number want to end with the digit 0, the factors the prime factors will be 2 or 5. Here only 2 and 3. Therefore, the number 6 raised to n cannot end with the digit 0. For example, if you are taking 4 raised to n, That also we can write 2 into 2 all raised to n. Therefore 4 raised to n also cannot end with the digit 0, because how we can write so there is a natural number. There are no other primes in the factorization of 4 raised to n. 2 and 2 only. If the number is ending with the digit 0 means there will be the factors 2, 5 like that. Therefore 4 raised to n also cannot end with the digit 0. Next, one more question I am explaining here. Just listen. Explain why 7 into 11 into 13 plus 13, 7 into 11 into 13 plus 13 is composite. You want to explain why 7 into 11 into 13 plus 13 is a composite number. You want to explain. From this, I am taking 13 outside. Then what will be the number? 7 into 11. This 13 also I have taken outside. Then this will be plus 1. Then this become 13 into 7 into 11. This then plus 13 into 1 means 13. Same number. Add 13. The 7 into 11 means 77. 77 plus 1. That is equal to 13 into 78. Again we are factorizing 78 to 39. Again 3. 30. Then thus we can write as 78. 13 into 78. Again we can write 13 into 78's factors you got 2 into 3 into 13. Again we can write this 2 into 13 into 13 square if you want. Therefore, now this number became the product of primes. So this is a composite number. We have studied every composite number can be expressed as the product of primes. Now this number also became as the product of prime numbers. Therefore, the given number is a composite number. Then what do you want to write here? Now this number expressed as the product of primes, so the given number is a composite number. Clear now? Okay.